All right, let's continue with our transformations of functions. For this next section, we're again going to look at an example where we graph two functions with tables of values to get an idea of what's going on. So let's sketch graphs of f of x equals x squared and, in this case, g of x equals x plus 3 quantity squared. So we're going to continue using f of x as our base function because it works pretty well. It's going to make our life easier if we're using the same function over and over again. So remember, for f of x, it's the same table of values: -3, -2, -1, 0, 1, 2, and 3. And then our y values are 9, 4, 1, 0, 1, 4, and 9. Now, we're going to make a table of values for g of x. And we could pick any values we want. We could pick the same x values. However, I am going to choose very particular values because I want to pick the values that are going to give us the most helpful information. So what I'm going to do is I'm going to pick -6, -5, -4, -3, -2, -1, and 0. Of course, we could pick other values, and all of those are going to give us points on the graph, but these are the x values that are going to be the most helpful. All right, so we need to figure out the y values now, our function values. Let's start with x equals -6. If we plug that in, -6 plus 3 gives us -3, and when we square -3, that gives us +9. Next, we'll move on to -5. When we plug that in, -5 plus 3 gives us -2, and when we square that, we end up with +4. If we plug in -4, -4 plus 3 is -1, -1 squared is +1. I think you might see what's going on here, but let's continue. If x is -3, -3 plus 3 is 0. 0 squared is 0. When we've got -2, -2 plus 3 is 1. 1 squared is 1. When x is -1, -1 plus 3 is -2. -2 squared is +4. And when x is 0, 0 plus 3 is 3, and 3 squared is 9. So we have several points to plot here as well. Let's get our xy plane and sketch these graphs. So for f of x equals x squared, it's going to be the same as it was in the last video. Same points. And we're going to have the same parabola that we've had before. Should look like that. Now, let's plot our points for g of x, which we're graphing for the first time. We've got -6, 9, which is going to go up there. -5, 4, which will go right there. -4, 1. -3, 0. -2, 1. -1, 4. And 0, 9. And we can connect the dots to draw a parabola. Still going to be a parabola when we multiply out x plus 3 times x plus 3. We still get a second degree polynomial equation. And so I want to ask, what's the difference between the original graph and the new graph? What has to happen to the original graph to change it, to transform it into this new one? If we look at each of the individual points, what's happened is they have moved to the left 3 units. And in fact, this whole parabola has been shifted to the left 3 units. So by adding a number to x, not to f of x, in the last one we took f of x, which was x squared, and we added a number to that. Here we're adding a number inside the function. We're adding something to x. And what that did was that caused us to have a horizontal shift. Let me give you the rule here, and then we'll look at another example. Suppose c is greater than 0. To graph y equals f of x plus c, shift the graph of y equals f of x to the left c units. This is exactly what happened here. We've got our function f of x, but instead of being evaluated at x squared, it's evaluated at x plus 3. So we've added 3 inside the function, and that means we shifted the graph of y equals f of x to the left 3 units. Now I want to use this rule to sketch a graph of h of x equals x minus 5 quantity squared. This follows the second part of the rule. To graph y equals f of x minus c, shift the graph to the right c units. So here we're shifting to the right 5 units. So every point on our original function is going to move to the right 5 units. So this point up here, 3, 9, is going to be moved to the right 5 units. So that's going to go up to 8, 9. And then the point 2, 4 moves to the right 5 units. So that's going to be at 7, 4. And then 1, 1 is going to move to the right 5 units. That's going to move to 6, 1. And then the origin is going to move to the right 5 units. That's going to go to 5, 1. And we keep going each point, oh, not that one, sorry. We're starting with the original one. Each point on the original graph gets moved to the right 5 units. And that gives us a point on the new graph. So this one here, 1, 2, 3, 4, 5 units. It goes right there. And then up here, 1, 2, 3, 4, 5 units. That goes up here. And then our graph of h of x is going to look like this. So whenever we're adding or subtracting a number to x, so if we're replacing x with x plus a number, or if we're replacing x with x minus a number, this corresponds to a horizontal shift. Now there's something a little bit interesting that's going on here. I want to compare these horizontal shifts to the vertical shifts we saw before. Before, when we looked at f of x plus c and f of x minus c, adding something to the function shifted the graph up, and subtracting shifted it down. Here, when we've got f of x plus c and f of x minus c, we end up shifting when we've got f of x plus c to the left and minus c to the right. And this is something that sometimes perplexes students. They think if we're adding something and we go up and subtracting something and we go down, that makes sense. Because on the y-axis, up is positive and down is negative. But when we look at the x-axis, things work in the opposite way we might expect. When we're adding a positive, we actually move to the left, and then when we're subtracting a number or we're adding a negative, we end up moving to the right. This is not intuitive. And I don't want to go into too long of an explanation for why this occurs, but I do want to show you another example where we had something similar happen. Remember when we looked at circles and we had something like x minus 2 squared plus y plus 4 squared equals 9, for example. Remember, in this situation, when we had x minus 2, this meant that the center of the circle had an x-coordinate of positive 2, which is to the right of 0 on the x-axis. It's a similar thing that's going on here that's actually going on with our problems right here. We've got an x minus 5 squared. That means we're moving to the right by 5. Here we had an x minus 2 squared. It means we're moving to the right 2. The actual answer is a lot deeper, and it depends on if we're looking at x as a function of y, if we're looking at y as a function of x, which variable is isolated in the equation. But effectively, because we're looking at y as a function of x, that gives us a very particular view, and we're treating y, our vertical stuff, and x, our horizontal stuff, a little bit differently. And I'm not going to go into any more detail right now, because already we've got a lot of stuff to cover this week. But in general, it's just important that you know that when we're dealing with horizontal transformations, they often work differently than the vertical transformations do, and we just need to keep that in mind.